Okay, this is homework 2, part C. So this one we need to derive an expression for the horizontal force on the circular end cap of a cylindrical tank of radius r when it is filled with liquid of density to a height of h. You can leave the final expression in an integral form to be evaluated numerically for specific values r and h. So I already drew our end cap here because we already know that the length of the cylinder doesn't matter. So we just need to focus on the end cap. So in this we have radius r. This will be our dh. This will be our big H, height of the entire end cap. This is going to be little h, distance from the fill line. And this is our width. So know that force is equal to rho g h. So now we can keep going with that. It's going to be the integral of rho g h, but it's also things that are changing are the width. The width changes, so w, and then also dh. So the best way to do this is to divide. So we rewrite this integral as it'll be 2 rho g, and then integral of h because it's in terms of h, and then the width. So that'll be related to sine of theta, and this thing over here is going to be theta. This top half is going to be x1. So 2 rho g h sine theta d h, and then the other integral 2 rho g h sine, let's just say phi dh. So now we need to get this sine in terms of x. So this top half is going to be x1, so across the entire thing. This top half is x1, and then the bottom is going to be x2. So I know that x1 is equal to big H minus the little h, and all that minus r. And you also know that cosine theta equals x over r. So now we're close to being able to put this into here, but we have it in terms of cos and we get it in terms of sine. So what we can do is we do sine theta equals 1 minus cos then we can plug in x minus r, or x over r for cosine, so equals right, so now we have it in terms of sine, so now we can plug this into here. Okay, so now that we have this in terms of sine, we can start to plug it back into our other equation. So this is still just f. F equals 2 rho g. And now we can start to put in our limits, and this one is going to be from, so this is 0, so we're going to say from 0 to big H minus R, and H times square root of R squared minus H minus little h minus R squared in terms of dH. Okay, and then we can do the other side. We're going to do it at the bottom, actually. Do it here. So plus 2 rho g. And so now this is from the bottom, so it's going to be, the limits are different, obviously. So from h minus r to h. So r squared again. And so this term, so this term is just like flipped, so it's negative for this one. So it's gonna be r squared minus God, h minus h. So now we can start to add these together. So f equals 2 rho g, and so these terms will cancel out. So it'll be from 0 to h. H is the same. That'll be r squared still minus r minus low power mode. Okay, r minus h minus h. This whole term squared. Now we're done.